Hi there, folks. Today we're looking at factoring by division. And the idea here is, sometimes polynomials get kind of big. We have a lot of terms. And some of our previous methods for factoring don't really serve us well when we're dealing with things that are really big. So we need to kind of jumpstart the process. And we jumpstart it either by guessing a value that might work or a factor that might work and dividing that thing out. And then getting our factored form, kind of jumpstarting the process of factoring by getting the first set of factors by dividing. Okay, and sometimes we'll have problems where one of the factors is given to us, so then we just have to divide that out to get this partially factored form. And then from there, we should be able to use our previous methods in order to factor the rest of the thing completely, okay? So we've used division almost to jumpstart the process to get this thing partially factored so that we can then continue to use some of our other methods for factoring in order to factor this thing completely. Okay, so again, we get the process started with some division. That'll give us a partially factored form, and then we can go from there. Now, for example, if I look at this first one, it says, given that x minus 1 is a factor of the polynomial below, we want to factor the polynomial completely. All right, and when we look at this, I have 6 terms here, and 6 terms is not something that we're used to factoring. All right, you could try things like factoring by grouping, but again, that's not something we're used to with 6 terms. Maybe you put these in groups of 2, or maybe you do groups of 3 so that I have 2 groups, and something like factoring by grouping might actually work here, all right? But because I'm given the factor of x minus 1, let's factor it with some division first, and then go from there, all right? And so the idea here is if I have x minus 1 as a factor of the polynomial, it says that x minus 1 is a factor of the polynomial, well, that means that the polynomial should factor into x minus 1 times something, okay? I don't know what that something is, but if x minus 1 is a factor of that thing, then it should factor into x minus 1 times some other polynomial, all right? And the way we can figure out that polynomial is, think about it, factoring is dividing out. So if I took this entire polynomial that I've started with here, and I factored out an x minus 1, that's the same as dividing out an x minus 1, okay? And so if I want to find out what goes in that blank set of parentheses, I just have to divide out the x minus 1. And so I'm going to use synthetic division to do that. So I'm going to come off to the side. And remember, I put in my box, I put a positive 1, because it's what x would equal in terms of that factor, that x minus 1, x would equal a 1. Again, synthetic division a lot of times is used for checking solutions. And I write down my coefficients, the 2, the negative 1, the negative 1, the 2, the negative 1, and the negative 1. Okay, so write down my coefficients, and now I'm just going to do my synthetic division. So I add straight down, that's a 2. Again, bring the 2 down because there's nothing to add right now. What's in the box times what's underneath? 1 times 2 is a 2. And then I add straight down, that's a 1. Now what's in the box times what's underneath? That's a 1. I add straight down, that's a 0. What's in the box times what's underneath? That's a 0. I add straight down, that's a 2. What's in the box times what's underneath? That's a 2. I add straight down, that's a 1. What's in the box times what's underneath? That's a 1. I add straight down and get 0. Okay? And it should not be surprising to me that I got a 0 for the remainder. We expected this thing to divide evenly because it said that it should. All right? The problem said x minus 1 is a factor, means it should divide evenly into this thing. So if we don't get a remainder of 0, well, it means we messed something up. Either we did something wrong or the problem is wrong. Okay, so just be aware of that. If the thing says it's a factor, well, of course it's going to divide evenly. It's going to give us a remainder of 0. Okay, and so the idea here is if I divided out the x minus 1, it left me with this thing down here, which if I interpret this, that's a 2x to the 4th plus 1x to the 3rd plus 2x plus 1 because I had a 0x to the 2nd in there. Well, that's what goes in this blank up here. That's this guy. Okay. And really, that's the nature of multiplication, division, and the relationship that they have together. If I had something like this off to the side, let's think about numbers. If I had like 12 divided by 4, that equals a 3. Well, working backwards, that means that 3 times 4 will equal a 12. It automatically gives me this. 3 times 4 equals a 12. Okay? And so that's the same idea here. If that original polynomial divided by x minus 1 gave me the 2x to the 4th plus x cubed plus 2x plus 1, then that means x minus 1 times that thing should bring me back to the original polynomial, okay? So again, we're just using synthetic division. We're using division as a way of factoring something out because I don't have a method for doing this, okay? And now from here, I want to factor this thing completely. Well, let's look at the thing that's in the parentheses. There's 4 terms. Well, this is the kind of stuff I'm used to doing for factoring by grouping, okay? And so for this one, out of that first group, I'm going to factor out, looks like an x cubed. Let me do a bracket here. That leaves me with a 2x plus 1. Out of the second group, remember, if it's factoring by grouping, you have to factor something out, so that's a plus 1. That leaves me with a 2x plus 1. So now my 2 factors here are an x cubed plus 1 and a 2x plus 1. And it looks like it's done at this point, but it's not quite there. One of these things can be factored further. It's one of our special cases, and it's that guy in the middle, the x cubed plus 1. That is a sum of cubes. And remember, sum of cubes, so this guy stays the way it is. We're not going to change that. But a sum of cubes factors into a binomial and a trinomial. Again, the 2x plus 1 just tags along for the ride. And so here we have this middle term, that x cubed plus 1. I got to split it up. And so following our rules, and remember, you know, these sum or difference of cubes, the thing that I think students struggle with is this is pure memorization. We have to memorize the pattern for the signs. We have to memorize what goes where and how we plug these things in. So I would start with the sign and say, okay, this sign is the same, this one is the opposite, and this one's always a plus. That's the idea of SOAP, okay? That's the thing we use to remember this thing. So I plug in the signs. I had an x cubed plus 1, so it was a plus. When I factor it, the first sign is the same, the second one is the opposite, and the last sign is always a plus, all right? And then to get this binomial over here, it's just the cube root. The cube root of x cubed is an x. The cube root of 1 is a 1, okay? For the trinomial, the first term, I just kind of use these pieces. I use this x and I use this 1, and I say, oh, hey, this guy goes right here, but I square it, so that's an x squared. And this guy, the second piece, goes right here and I square it. That's a 1. And then the middle piece, I just take those 2 things that I have in the boxes and I multiply them. X times 1 is an x. And that's it. And again, this is all memorization, all right? You can't logic your way through this one. You just have to memorize the patterns and what goes where. And now this thing is factored completely, okay? You could try factoring that trinomial that's left, but spoiler alert, it's not going to work, okay? If I look at the next one, here I have x equals 10 as a solution of the polynomial below. And so if I want to factor the polynomial completely, all right, once again, I'm going to start with that 10. And notice this time I have 4 terms. So you might think, hey, let's do factoring by grouping. And you could try that, but spoiler alert, it's not going to work, okay? Factoring by grouping is not going to work this time. So I have to use that x equals 10 in some way, shape, or form, okay? And now here's the thing. If I want to divide this, all right, the thing that I have to figure out first is what factor am I dealing with, okay? If x equals 10 is a solution, like if this is one of my zeros, x equals 10, what is the factor that I'm trying to get at, okay? And so if x equals 10 is a solution, that means x minus 10 must be one of my factors, okay? Think about it. If x minus 10 is a factor, that'd be like x minus 10 equals 0. Well, that's what would produce the x equals 10. Okay, and I point that out for a couple reasons. One, when we're doing this, that's what we're actually dividing by. We're going to divide this by guy by x minus 10. Okay, or x minus 10. The other thing is this: when we go to put this in synthetic division and do the division here, we have to remember that what goes in the box is the solution of that factor. So what goes in the box is actually the 10 that was given. Okay, a lot of times students will reverse that 10. But if you think about the factored form of x minus 10, that's the thing you reverse, okay? So it's a positive 10 that goes in the box. And then the last reason, when I go to factor this thing, put it in factored form, I need an x minus 10 as one of my factors, okay? That's what I'm dividing out in terms of the factored form. So that's what goes out here, and now I have to find the piece that goes inside those parentheses, okay? That's where I'll use this synthetic division. So let me write down my coefficients. And then here we go. It's a big addition problem, 1 plus nothing, so this guy just comes right down, all right? And then what's in the box times what's underneath, and I add straight down. What's in the box times what's underneath, and I add straight down. What's in the box times what's underneath, and I add straight down. And I get a 0 for my remainder. Of course I do. This thing is a solution. It's a factor, so it should give me a remainder of 0. Okay? And then interpreting this guy, that's an x squared minus 2x minus 8. So that means if I divided out the x minus 10, it left me with an x squared minus 2x minus 8. And again, it's once again just that idea of dividing something out gives us the multiplication form of this thing. 12 divided by 3 is a 4, so 4 times 3 is a 12. Okay? This polynomial that I have divided by x minus 10 gave me an x squared minus 2x minus 8. So that means x squared minus 2x minus 8 times the x minus 10 will bring me back to the original polynomial. Okay? So we're using division to get to our factored form. Okay? So now I have this partially factored form. I just continue to factor what I have here. This one, I build a bridge. Build a bridge, two numbers that multiply to a negative 8 but add to a negative 2 are going to be a negative 4 and a positive 2. I can even use my shortcut on this thing because there's a 1 out front. So I can go right to this, x minus 10 times x minus 4 times x plus 2. And that's it. Okay, now this thing is factored completely. If I look at something like this guy, this is a pretty tricky one, but notice I've got x equals plus or minus 2i, okay? So x equals plus or minus 2i, and here's why this one is a little bit tough, okay? Because I have a 2i, I have to think about the idea of getting imaginary or complex solutions, okay? And one of the things you should always notice is that whenever we have a complex solution, they always come in pairs. They're always a plus or minus. So that means if x equals 2i is one of the answers, then x equals a negative 2i is also one of the answers, okay? These never exist by themselves. It's always two complex solutions, never one, okay? Because the fact of the matter is, to get a complex solution, I would end up taking a square root somewhere, which means I would have a plus or minus. So it's really this. I actually have two of these things. But now the idea is working back to the factor that we want, okay? See, if I look at the previous one, this is a lot easier to think about. But if I had something like x equals 10, I can easily work back to the factor, all right, by making sure I get a 0 over here. Watch this. I just go, hey, let me subtract 10 from each side. And now I've got x minus 10 equals 0. And I can see that's the factor that I've been using right here, okay? So that idea of working backwards, well, let's apply that same thing here. Think about how you would have solved to get to this point. I just work backwards. It's this idea of reverse engineering our reverse engineering, okay? We're undoing the process of undoing. So if I looked at something like this guy, to get rid of that I and to get rid of the plus or minus all in one shot, I can go ahead and I can square each side. Watch this. If I square each side, that's an x squared equals, well, that's going to be a 4 times I squared. And I squared is a negative 1, so that's a minus 4. Okay? And now I could add that 4 over to the other side. I get x squared plus 4 equals 0. Okay? And there's lots of different ways that you can get this. All right? I could think of it like this. I could say, oh, well, if 2i is one of the answers, then x minus 2i has to be one of the answers. It has to be the factor. Okay? And then if x equals a negative 2i, then x plus 2i has to be one of the factors. And then I could distribute there. I could multiply this out. Spoiler alert, if I multiply that out, I get x squared plus 4, okay, when it's all said and done, okay? And so it's the idea of just working backwards to get to the factor, okay? To get to that solution, I would have solved. Well, let's undo the process of solving. I square each side instead of the square root, okay? I move that guy back over. Now I can see this is the factor. This is what I want to divide by. So I'm going to divide off this x squared plus 4. And this time I can't use synthetic division. I have to use long division because it's not a first degree binomial. So I have to do my long division. Don't forget to put the 0 in for that missing term here. And away we go. Here we go. Ready? So I say x squared goes into x to the 4th. How many times? Or times what will give me that? So this is going to be an x squared. And now I multiply to the fourth plus 0x cubed plus 4x squared. And now I subtract. And remember, I'm subtracting this whole thing. I like to distribute that negative, change it to adding the opposite. And so let's see, that gives me a negative x cubed minus 6x squared. And then I can bring everything else on down for the ride. And now I say, okay, x squared to become a negative x cubed, I'm going to need a minus x here. And now I multiply. And once again, I'm going to subtract. Again, I like to distribute the subtraction, change it to adding the opposite. And so what happens here, all this stuff cancels out. It looks like I'm left with a minus 24 here at the end. Or sorry, I missed the minus 6x squared. There it is. And I bring down the minus 24. And now this has to multiply. That's going to be a negative 6 to give me that thing. And now I multiply. It's a negative 6x squared. Plus, sorry, I should have kept the 0 in here. Let me space this back out. I'm ashamed. I'm ashamed of myself. Come on. You're better than this, Mr. Jansen. Let me keep that 0 in there. Oh my goodness. 0x minus 24. And now hopefully you see that these are the same things. So when you subtract, you get a 0. And of course, you should get a 0. If you get anything but a 0 here, well, then there's a problem. All right. We knew this thing should be a factor, which means it should divide evenly. But now let's think about the factored form. Let me take it off to the side over here. So the factored form then is this. I divided out the x squared plus 4, which essentially is factoring out the x squared plus 4. And it left me with an x squared minus x minus 6. Okay? And now I continue to factor what's left. That trinomial, build a bridge. Sorry, let me give myself a little space here. I can go right to the answer. I build a bridge. I get to use my shortcut and everything. Two numbers that multiply to a negative 6 but add to a negative 1 are a minus 3 and a positive 2. And that's it. Okay? But see, it's the division that got the process of factoring started. Okay? So again, use division to break this thing down into a slightly factored form and then continue to factor using your previous methods, okay? This last example, this is about as tricky as they come, but just be aware, if it says x equals this thing, if it says that's a solution, you got to work backwards to the factor, okay? So get that thing equal to 0, work backwards to the factor that would have given you that answer, okay? And then again, divide it out. That gives you a partial factored form, and then continue to factor using your previous methods. Okay?